Hello and welcome everyone. So shortly we are going to be starting with our webinar, Material Flow System in SAP EWM, and we will be showing you a basic process demonstration on the screen, as well as we will be discussing the functionalities and advantages of Material Flow System in SAP EWM. So let's dive into the presentation. But before starting, I'd like to briefly introduce logistics team here at MDP Group. So currently we have got 16 team members in MDP Group, and my name is Eren Öztürk. I've been a part of this great team since 2022, and we have been serving clients from a wide range of industries on an international scale, as well as national projects throughout Turkey. About logistics executions applications that we have in our services, we have got process design optimization, process automation, as well as technical support and key user trainings in our portfolio. And we offer our consultancy services for the setup, support, and further development on embedded or decentralized SAP systems, focusing on EWM module. In addition to EWM, in our logistics team, we have also experts at transportation management and GTS modules as well, and also integrations with other SAP modules we are also having consultancy services on. And without further ado, let's start with today's agenda. What we are going to be talking about today with my colleague Umut is material flow system and its functionalities inside extended warehouse management. So what is material flow system? It is basically a component in EWM that enables you to connect an automatic warehouse and its components directly to the EWM system without any third party or additional warehouse control unit. And thus, in order to talk to the automation equipment and the warehouse management system, you'll just be using one interface, and all your controls over the material flow will be conducted in an integration with EWM. For processes like pick, pack, and pass systems, for automated put away processes, and also automated stock removal processes, in many industries, it is currently a very efficient tool to use. And through automatic guided vehicles, it helps you control your warehouse processes inside EWM with the help of MFS functionalities. The features of MFS include automatic identification and diversion of handling units, so using scanners on automatic storage removal facilities, and HUs that cannot be stored directly using diversion techniques. Fully automatic processes are possible in MFS. Also, malfunctions or any capacity limits exceeding any capacities are controlled on communication points, and directly interim steps or any other processes are taken through telegram messages sent by the programmable controllers to the EWM. And in addition to these, EWM Monitor, so Warehouse Management Monitor, enables you to track the current state on the system, evaluate the telegrams or response times, and also it enables you to manually confirm any warehouse task at any point of need. When we come to the benefits of MFS connection to the EWM, as mentioned before, there is no need to any interim warehouse control unit. So thus, EWM directly connects to the PLC, including the material flow system, and you can control any kind of automation without any external material flow system. So this will enable you to reduce the number of interfaces and number of workers that you need to use inside in the warehouse processes, and you will only have one responsibility for warehouse management and material flow control, and thus you can use only one SAP system landscape when you are completing your automated warehouse processes. And at the first implementation effort, it also reduces the effort that is required, because there will be no need to set up an extra control unit and then connect it to the EWM system that you are using. But you can also you can already control your hardware or business process requirements through one source of data, which is SAP EWM. And further advantages include lower risk of errors. So due to automated and tested processes, decisions are always made in the same way on the base of a given situation. So a significant reduction in manual intervention and manual movements result in fewer user errors. It also improves performance because in a like the, you need shorter transport distances to touchdown points, and you have faster processing by requests as the system carries them out automatically again. And because of automation at almost each movement, you will end up with fewer manual interventions, and thus they will be only necessary for correcting errors or placing or removing some pallets. So having talked about the benefits of MFS, I'd like to go deep into the components that MFS has got, and need to be customized and defined on EWM system, so that whole process can work uh, without any problem using layout oriented storage control. So the MFS components include the following on the screen. So it communicates, the system communicates with programmable logical controllers, PLCs, through communication channels, and then using conveyor segments and communication points, the telegram messages sent in and out, so that the necessary actions can be taken automatically by PLC or manually by the warehouse workers. Uh, Before I dive into the definitions, I would like to explain layout-oriented storage control briefly. So layout-oriented storage control in extended warehouse management basically deals with the physical layout of your warehouse, and, for example, moving a product from a high rack bin to the bulk storage area or vice versa can be controlled through layout oriented process storage control. And you can use interim steps, which are really important in MFS processes, because we define identification points where scanners are going to scan the handling units, and thus maybe decide on their final destinations, or decide if they are okay to move on or not in a basic MFS put away or stock removal process. So let's talk about programmable logical controllers. So these are basically a small industrial computers which consist of multiple modules, and in MFS, through MFS configuration in EWM, they connect and they communicate with your warehouse management system. The PLC evaluates the signals from like storage retrieval or conveyor systems or other activities, and then activates or deactivates motors, appliances, sensors, readers, etc., according to your automated warehouse needs, or requirements. Each control that is to communicate with EWM system must be defined in the system as a PLC, and after you define a PLC, at least one communication channel must be defined. A communication channel is the connection for transmission of messages between MFS and PLC, and it is usually defined by an IP address and a port. So to facilitate this communication, MFS and PLC, uh, a communication channel for a specific PLC should be defined, and in the process, certain properties such as length of the messages, whether the confirmations are to be used or not, should also be defined in order to send and receive uh, correct telegrams using these communication channels. We also have communication points which are defined as storage bins in the EWM system, and at every communication point we assign one PLC, and through using of scanners they can be used as reporting points, action points, segment points, again depending on your automated process. So these can be used as storage retrieval system to communicate with the PLC and maybe complete some destination definitions or HU checks on this points that we define on a EWM level. Also, MFS uses conveyor segments. These can be many different forms, and they physically transport your handling units from one communication point to the next, and these conveyor segments are assigned to your start and end points as we define in layout-oriented storage control. Thus, they complete the physical transportation of handling units without any uh, manual manual effort. You can also define capacity limits, which are quite important when it comes to conveyor segments. So this can be the number of HUs that can be placed on a certain conveyor segment, or this can be the weight or volume of a certain HU type that can be used at a certain conveyor segment, etc. And PLC, by using scanners, can decide on which conveyor segment the HU is going to be transmitted next by checking capacity limits and additional properties if defined in the system. And the routing depends on making the right decision at the right time, and MFS in EWM makes it for you through communication of PLC and EWM. And the last the last unit that we define on the system is an MFS resource. It is basically the objects that perform a warehouse task for you. For example, stacker cranes uh, can be used for these purposes. And in the MFS, in EWM, we define cranes as resources on MFS system, and they are represented as vehicles that transport the handling units from the communication point or the storage bins to another, or another store to the another storage area that we have. So to optimize the movements of these cranes or these MFS resources within EWM, we need to map them as resources on the system so that we can use additional EWM functionalities as well as MFS. And the last and the most important maybe unit component in MFS is the telegrams. A telegram refers to a standardized data message that is utilized to exchange information between different components. This can be PLC and EWM. So in a logistics or automated warehouse system, telegrams play a crucial role in facilitating real-time communication, which is the point when we are designing an automated warehouse process using material flow system. So telegrams can have different types and can be in different categories. These can all be defined in the system in accordance to your requirements, business or hardware requirements, and then these messages from or to EWM sent by PLCs or the other way. So right after my presentation, we are going to be showing you, displaying you a real life process demonstration on the screen. And when we are doing that, we'll also talk about these more in detail. But uh, one of the most significant ones, live telegrams, are important because they indicate the connection is set and there is no problem in the connection between EWM and PLC, and they can be triggered in a uh, time interval of your choice so that you can check the connection between EWM and PLC. Also, if you want the PLC to confirm any warehouse task, it will send you a telegram type of WTCO, warehouse task confirmation, so that it indicates you that a task has been executed. In Warehouse Management Monitor, we can track these objects and much more about material flow system in the uh, material flow system node on the left-hand side of Warehouse Management Monitor. So here, for the communication channels, you can stop, restart, or start individual connections for individual PLCs with the EWM. Also, you can display the list of communication points and their current status. And if there is any malfunctions at any certain communication point, you can also display that, and you can lock or uh, have additional processes about those malfunctioning parts, etc. And for the telegrams, you can display the logs of PLCs that the telegrams that have been received or sent, and their status can be seen. And if a telegram is received but could not be processed by for any reason, you can display them in Telegram buffer node, and you can check inbound or outbound buffers with the error flags, and then where appropriate, you can manually correct and flag them for posting if you just fix the malfunctioning in that area. You can also call up a status overview or manually lock, unlock resources, MFS resources on this part. You can also display HU movements, handling unit movements, entries that are created as a routing decision and a tentative reservation, and this can be as a result of put away strategies, rough destination bin determinations, or stock removal strategies. Related actions can be tracked on Warehouse Management Monitor. So briefly, we are going to be diving into the system and talking more in detail about these. Uh, but here we can see a basic flow of MFS and PLC communication. So just like mentioned before, the communication channels should be defined and started on Warehouse Management Monitor, and then the MFS sends message to the PLC. If that gets accepted, then you can see the status of your and you can control the requests that you send, and MFS and PLC uh, keep communicating to each other. Then the PLC can send you the general system state, and if it is accepted, you can process equipment states, and the PLC is finally getting connected. And the process flow that we're going to be having here is that after creation of warehouse task, a picking warehouse task specifically, uh, the using layout oriented storage control EWM is going to communicate with the PLC, and after the sensors receive the signal, of course, in our example, for the sake of this webinar, we don't have physical PLCs, but we are going to simulate the real life process by simulating the telegrams at every point, and we are going to create the relevant warehouse tasks, as well as systems going to create automatic warehouse tasks, and PLC is going to send us relevant telegrams, and we are going to follow further. Now, I'd like to leave the stage to Umut, my colleague Umut, and he will be demonstrating you a basic outbound process using MFS in EWM, and then we'll be here again with you. Thank you for now.
Hello, Eren. Thank you for your presentation. Today I will present a demonstration for MFS. Our demo will show basic MFS process for picking of outbound deliveries. So let me start. So I will create an picking task for outbound delivery. Now I will create an picking tasks. Now system determined material will be picked from Hirect via MFS and created 2 warehouse tasks. So let's check warehouse tasks. Okay, here we have 2 warehouse tasks. The first step is manual. Warehouse worker will put a handling unit to vertical conveyor system. So when it is done, first warehouse task will be confirmed. So let me confirm that warehouse tasks. Now materials in the horizontal conveyor system. So we have other warehouse tasks, but it has a status of waiting since system determined that MFS will take over from there. So during that process, material will be proceed in MFS and conveyors. So when it finally reaches the scanner, MFS will send a telegram to EWM system. So unfortunately, we don't have real MFS. We will simulate that step. So let me send the simulation telegram. Telegram will be from PLC to EWM system. And scanner will also scan handling unit ID. So let me create a telegram. Now Telegram is completed. Let me check. Let me show. Now we can see that materials in the horizontal conveyor. So we can see that materials here. So during that process, based on the customization, EVM will route a handling unit and send another telegram to route material to send material to correct workstation. So for now, we have 4 workstation, and EVM will route material based on the customization. Now let me check warehouse tasks. Now our there is our final step. It happens when conveyor reaches to workstations, and workers will confirm warehouse task when they pick the actual handling unit. So when I confirm that warehouse tasks, picking will be completed actually. So that was the basic MFS process for picking outbound deliveries. That was all. Thank you for listening. Do you have any words?
So yes, let me just end the session. Thank you, everyone. That was, of course, a very basic presentation of a system process, and MFS has got more functionalities, more features, and it is highly customizable in accordance with your business needs or process needs in your warehouse. So if you have any questions or anything you'd like to share with us, any feedback, please let us know on logistics@mdpgroup.com. Send us an email. We'll be happy to get back to you as soon as possible. And thanks for participating, and thank you for your time. That was all from us. Have a nice day.